Electrochemical Changes, Chapter 13. In this section, we will explore batteries. We will see that batteries are made up of electrochemical cells arranged in a series or a parallel configuration. We will see what difference this arrangement of cells makes when considering voltage, and perhaps explain the reason why a small watch battery has the same voltage as a D-cell battery, many times its size. A Voltaic cell is an electrochemical cell that uses redox reactions to transform chemical potential energy into electrical energy. Another type of electrochemical cell is the electrolytic cell, and that converts electrical energy into chemical energy. We'll talk about the electrolytic cell later. Usually, to make a redox reaction work, we put a strong reducing agent, say zinc metal, into a solution of copper ions, a strong oxidizing agent, shown in the picture on the left. There, electron transfer can occur between the two, zinc metal giving up 2 electrons to the copper ions. The zinc metal begins to disintegrate into copper ions, while the copper ions become copper metal, as shown in the picture on the right. Now, instead of having the electrons transfer directly from the zinc metal to the copper ions in the solution, a Voltaic cell separates the two half reactions, connecting them only by a conducting wire. The electrons pass from the zinc to the copper ions by way of the wire. The movement of electrons in this way through an external circuit is an electric current. The energy in these electrons can be used to do work, such as light a bulb. The magnitude of the energy in the electrons is dependent upon how strong the oxidizing agent is relative to the reducing agent. Your book illustrates the Daniell cell, showing a strip of copper placed in a solution of copper ions, and a strip of zinc in a solution of zinc ions. The two strips are connected by a piece of conducting wire. A voltmeter attached to the wire displays a voltage. The energy in the electrons, or electrical potential, is measured in volts, and is determined by the composition of the reducing agent, the substance losing the electrons, and the oxidizing agent, the substance gaining the electrons. The metal strips, or conductors that carry electrons into or out of the cell, are called electrodes. I'll return to the details of this illustration in a moment. Each electrode is in a solution of its own ions, so that one doesn't react with the other. A solution of ions is called an electrolyte and permits the movement of electrons. This is the illustration of the Daniell cell again. The zinc electrode is connected to the copper electrode by way of a conducting wire. The voltmeter along this wire measures the energy in the electrons passing through it. Remember, the amount of energy is determined, among other things, by the materials of the oxidizing and reducing agents. This is one reason why the voltage of the battery is not necessarily related to its size. There are a couple of new terms here. The electrode where oxidation occurs is called the anode. The electrode where reduction occurs is called the cathode. For experimental purposes, chemists find it useful to separate a Voltaic cell into two half cells, the anode half cell and the cathode half cell. Here, the zinc metal is losing electrons. For every 2 electrons lost, 1 zinc ion is added to the solution from the electrode. The electrons pass through the voltmeter and head toward the copper metal. It is not the copper metal that is gaining the electrons, rather the copper ions, which move toward the copper electrode by charge attraction, combining with the electrons to form copper metal. In a Voltaic cell, the anode loses mass, and the cathode gains mass.